Hey everyone, and welcome to another deep dive with us.
Yeah, glad to be back.
So today we're going to be tackling
Quantum mechanics.
quantum mechanics, but not just any old quantum mechanics, right?
Right.
We're going deep into something called the transactional interpretation,
Or as the cool kids call it.
or TI for short.
Yeah.
It's all about how quantum events, like, create the reality we actually experience. It's like, how does that actually work, right?
Yeah.
And we've got this
Great article.
awesome article that really breaks it down. And trust me, it gets
Pretty wild.
It gets wild.
It gets out there.
Okay, so I think before we jump into like the really nitty-gritty, I kind of want to set the stage a little bit. Like
What is it?
what is the transactional interpretation?
Yeah.
Because it's a kind of a different way of looking at quantum mechanics, right?
Yeah. So, I mean, what's really fascinating about it to me is that it tries to explain not just how tiny particles behave,
Yeah.
but the very nature of space and time.
Whoa. It proposes that those fundamental aspects of reality actually emerge from the interactions between those quantum entities.
So instead of thinking of space and time as like this pre-existing backdrop, TI suggests that they're actually built from these tiny little quantum interactions.
Yeah.
That's a huge shift.
It is a huge shift.
Yeah.
It's not what you typically
Think about when you think about space and time.
No. Okay, so before we I feel like we're already getting ahead of ourselves.
A little bit.
A little bit. Let's
Yeah.
break it down. What exactly is the transactional interpretation?
So, imagine the universe not as a collection of static objects, but
Right.
as like this constant dance of possibilities,
Okay.
right? In TI, every quantum event is part of a kind of cosmic negotiation,
Ooh.
a transaction between entities.
Okay.
And these transactions are what give rise to the reality that we observe.
Okay, so it's not just about like the particles existing in isolation. It's their interactions, their relationships that actually matter.
Their relationships, that's right.
Yeah, it's
Like transactions.
it's like saying that the universe is built on connections, not just things.
That's a great analogy. Yeah, and it's in these these transactions that we actually see the seeds of space-time itself.
Whoa.
Yeah.
Okay, so one of the things in this article that really blew my mind
Yeah.
was this idea that space-time is somehow tied to the electromagnetic field.
Yeah.
Like how does that work?
Well, think about the fundamental forces of the universe. You've got the weak force, the strong force, and the electromagnetic force.
Okay.
The weak and strong forces, they act very locally.
Right.
But the electromagnetic force, it has this very unique ability to span vast distances.
Yeah.
Right? So TI proposes that it's this far-reaching nature of the electromagnetic field that actually gives rise to the structure of space-time.
So the electromagnetic field is like the architect of our reality.
Yeah,
Shaping the stage where everything kind of plays out.
precisely.
Wow.
And what's even more mind-blowing
Okay.
is that TI doesn't consider gravity to be a quantum field.
Wait, what?
Yeah,
Gravity isn't a quantum field.
gravity is not a quantum field.
But how does that like fit in with everything else?
Right. So that's one of the really bold claims of TI.
Yeah.
It suggests that gravity isn't a force acting on space-time,
Okay.
but rather an inherent property of space-time itself. It's like the curvature of a rubber sheet.
Right.
It's built into the very fabric of reality.
Okay, so I'm trying to like wrap my head around this.
Yeah.
So instead of like trying to quantize gravity like all the other forces, TI says that it's already there, woven into the fabric of space-time.
That's exactly it. Yeah.
But doesn't that create a whole new set of problems?
Well,
I mean, physicists have been trying to reconcile quantum mechanics and general relativity for decades.
you're right. It is a radical departure
Yeah.
from most approaches to unifying physics.
Yeah.
But TI argues that this view of gravity as an emergent property of space-time could actually be the key
Okay.
to resolving this conflict between quantum mechanics and general relativity.
Okay, that's a bold claim. I gotta be honest, I'm still a little bit skeptical,
Right.
but I'm willing to hear you out.
Okay, good.
So if TI is right, does that mean that it's claiming to be like a theory of everything?
Not quite. So the author is very careful to point out that while TI offers a very powerful framework for understanding the physical world,
Yeah.
it doesn't claim to answer every question.
Okay.
Right. So it's not about explaining consciousness or, the meaning of life.
Right.
It's specifically focused on the realm of physics and how quantum interactions shape the observable universe.
So it's not about explaining the why of the universe.
Right.
It's the how.
It's the how.
Yeah.
It's about the nuts and bolts of how reality works at the most fundamental level.
Okay. Yeah,
Yeah.
that makes a little bit more sense to me.
Good.
So one of the most intriguing hows, right, that Ty tackles is this issue of non-locality, right?
Yeah.
That spooky action at a distance
The action at a
that
distance.
Einstein
Yes.
hated.
Famously disliked,
Right,
right?
yeah.
But TI doesn't try to, like, shy away from that, does it?
No, it embraces non-locality
Yeah.
as a fundamental aspect of reality.
Okay.
In fact, TI suggests that it's a natural consequence
Yeah.
of the way that quantum entities interact.
Okay.
You see Bell's theorem,
Right.
and it's worth mentioning that this theorem is a cornerstone of modern physics,
Yeah.
basically proved that the universe is inherently spooky,
Yeah.
right?
Yeah. That particles can be linked in ways that defy our classical understanding of distance.
So, I mean, I think what we have to accept is that, at least at the quantum level, sometimes things are just weird.
They are weird. Yeah.
Right.
Sometimes things are just weird.
But how does TI explain non-locality, well, like completely breaking
Yeah.
our understanding of cause and effect?
Right.
Right? Because those two seem kind of at odds with each other.
Well, you know that analogy about Flatland?
Yes.
The one about the two-dimensional beings that can't perceive a three-dimensional sphere passing through their world.
I love that analogy.
Yeah.
Yeah.
It's great.
It's a great way to like visualize
It is.
how higher dimensions might influence lower ones.
Right. So TI suggests that what we perceive as spooky action at a distance
Right.
might just be a higher dimensional interaction that we can't fully grasp
Right.
from our limited perspectives.
Like we're the Flatlanders.
We are.
And we're like, what is that?
Exactly.
Yeah.
Imagine a being from a higher dimension.
Yeah.
You interacting with our world. To us, their actions might seem instantaneous.
Right.
Unconstrained by the laws of physics as we know them.
Right. Right. Yeah. Okay. So if TI is correct, then our everyday notion of cause and effect is just the tip of the iceberg.
That's right. It's just the tip of the iceberg.
Yeah. There's a whole hidden layer
Yeah.
of quantum causality underneath.
Of quantum causality underneath.
Yeah. Okay. But if everything is so interconnected,
Yeah.
so spooky, right?
Yeah.
Does that mean that our universe is inherently chaotic?
Well, that's a great question.
Yeah.
And it brings us to one of the most important concepts in TI, the distinction between causation in the quantum realm
Okay.
and causation in classical spacetime.
Okay. I'm intrigued. What's the difference?
So in the quantum realm,
Yeah.
the realm of possibilities and transactions,
Yeah.
things can be non-local, apausal, even seemingly backwards in time.
Yeah.
It's a world where the rules of classical physics don't necessarily apply.
Right.
But when those quantum transactions play out,
Yep.
they manifest in the world we experience, the
Yeah.
world of classical spacetime.
Right.
And in that world, cause and effect
Yeah.
appear more linear and predictable.
So it's like there's this hidden quantum level of causality that's driving the more familiar classical level.
That's a great way to put it. Yeah,
Yep.
okay. It's a great way to put it.
But how can something so seemingly chaotic
Yeah.
give rise to the ordered universe that we experience?
That's where the concept of emergence comes into play.
Ooh.
But I think that's a topic for our next section.
Ooh, cliffhanger.
Yeah. Got to keep them coming back for more.
All right. Well, we'll pick that up next time. But for now, thanks for listening, and we'll see you on the next deep dive.
See you then.
Bye.
Bye. So where were we?
Emergence.
Emergence, right.
Yeah, you were about to tell me all about emergence.
I was. It's this idea that complex systems, they can exhibit properties that aren't present in their individual parts.
Okay.
Right? Think about a flock of birds.
Yeah.
Right? Each bird might be following some really simple rules.
Yeah.
But together they create these really intricate, almost intelligent patterns.
Right. The whole is greater than the sum of its parts.
Exactly.
So how does this concept of emergence apply to TI?
So TI proposes that many of the things that we consider to be fundamental in the universe, like space, time, even gravity,
Yeah.
might not be fundamental at all.
Yeah.
Instead, they could be emergent phenomena arriving from the countless interactions between those quantum entities.
So instead of space-time being this like fixed background where quantum events happen, TI says it's actually built from those events, from those transactions.
That's right, yeah.
So it's like the stage is created by the very play that's being performed on it.
That is a fantastic analogy.
Yeah.
It really captures the essence of emergence in TI. Each transaction, each interaction between quantum entities, it adds another thread to the tapestry,
Yeah.
contributing to the emergence of that macroscopic world that we observe.
I'm starting to see how this could be like a real game changer for physics.
It could be, yeah.
You mentioned before that one of the biggest challenges is unifying quantum mechanics with general relativity.
Right.
Does TI like offer a solution to that?
It just might.
Okay.
You see, general relativity, it describes gravity as this curvature of space-time,
Right.
whereas quantum mechanics focuses on the behavior of matter and energy at the smallest scales.
Right.
These two theories, they seem fundamentally incompatible. It's like trying to fit square pegs into round holes.
Yeah, I remember from physics class, those two just they don't play nice together.
They don't. They don't. But what if gravity isn't a fundamental force at all?
Okay.
What if it's an emergent property of space-time itself?
Okay.
Just like TI suggests, if space-time arises from these quantum transactions and gravity is just the shape of that emergent space-time,
Yeah.
then suddenly the conflict disappears.
Whoa, hold on. So you're saying that instead of trying to force gravity into the quantum framework, TI says it's already there, baked into the very fabric of space-time.
That's the radical idea at the heart of TI.
Okay.
It suggests a paradigm shift in how we think about gravity.
Yeah.
It's not a force acting on space-time, but a consequence of the structure of space-time itself.
That's a lot to process.
It is.
It's a lot to process, but it's also incredibly exciting.
It is.
I mean, if TI is right, it could like revolutionize our understanding of gravity and its relationship to the quantum world.
It could. It really could.
But this whole concept of emergence,
yeah.
it makes me wonder, like if space-time and gravity are emergent properties, what else could be?
Right.
Could things like consciousness or free will also emerge from the quantum realm?
Those are fascinating questions.
Yeah.
And while TI itself doesn't directly address those topics,
Right.
it certainly opens up new avenues of exploration.
Yeah.
If the very fabric of reality, space-time itself,
Yeah.
is emergent, then who's to say what other possibilities might arise from that quantum foam?
I'm getting chills just thinking about it. I have to admit, when I first heard about TI, I thought it was just going to be another like abstract theory.
Right.
But the more we delved into it, the more I realized how profoundly it could change our understanding of reality itself.
And that's what's so compelling about TI. It's not just about explaining the universe as we currently understand it,
Right.
but about expanding our understanding of what's possible.
Yeah.
It challenges us to rethink our assumptions about what's real,
Right.
what's fundamental,
Yeah.
and the role we play as observers in this cosmic drama.
Speaking of the role of the observer,
Yeah.
that's one of the things that often gets lost in discussions about quantum weirdness.
Right.
How does TI address the idea that the act of observing something seems to affect the outcome?
That's a crucial point.
Yeah.
And it brings us to the heart of what makes TI unique.
Okay.
You see, in traditional interpretations of quantum mechanics,
Yeah.
the act of measurement is often seen as somehow collapsing the wave function,
Right.
forcing the universe to choose one outcome from a multitude of possibilities.
Right. It's like the act of observation is creating reality.
Right, right.
But that always felt a little bit too mystical for me.
Too mystical, yeah, yeah.
Okay.
TI offers a different perspective.
Okay.
Instead of seeing measurements as causing a collapse, TI views them as the culmination of a kind of quantum dance.
Ooh, a quantum dance.
Yeah, a quantum dance.
Okay, I like where this is going. Break it down for me. What's this quantum dance all about?
All right, so imagine two dancers on a stage.
Okay.
Right, they're moving in sync, anticipating each other's movement,
Yeah.
responding to each other's energy.
Yeah.
In TI, quantum interactions are like this dance.
Okay.
They're happening constantly, creating this field of possibilities, this web of potential outcomes. But it's not until a measurement is made
Yeah.
that one of those possibilities becomes actualized.
So the measurement isn't collapsing anything. It's simply revealing the outcome of this quantum dance.
That's a great way to put it. Yeah.
Okay.
It's like the dancers finally choosing a pose at the end of their performance.
I like that. Okay.
Right? And the beauty of this is that it respects relativity.
Okay.
There's no information traveling faster than light, no violation of causality.
Yeah.
The quantum dance, it might be non-local,
Yeah.
but the outcomes that we observe, they're always consistent with the laws of physics as we know them.
Okay, that makes me feel a little bit better.
Good.
I'm starting to see how TI weaves together so many different threads from non-locality to emergence to the role of the observer. But there's another piece of the puzzle mentioned in the article that I found like really intriguing, the Koch-Inspector theorem.
Yeah, that's a fun one.
What is that about, and how does it tie into TI?
The Cauchy-Spector theorem, it's a mind bender for sure.
Okay.
But it essentially highlights the importance of context in quantum mechanics.
Okay.
It tells us that certain properties of quantum systems, like the position or the momentum of a particle, don't have definite values until they're measured.
So it's not that these properties are hidden or unknown, but they don't actually exist until the act of measurement brings them into being.
It's a very strange concept.
It seems to defy like common sense.
It does, but that's the quantum world for you.
Yeah, okay.
And this concept of contextuality, where properties only manifest upon interaction, it ties in beautifully with TI. Remember those transactions we talked about?
Yeah.
Well, in TI, it's the transaction itself, the interaction between the observer and the observed,
Yeah.
that defines the context
Okay.
and brings about those observable properties.
So it's not just about particles interacting.
Yeah.
It's about the act of observation being an integral part of the process of reality making.
That's a great way to put it.
It makes the universe seem even more participatory than I initially thought.
It does. It really does.
I have to say I'm still struggling a little bit with this idea of contextuality.
Yeah.
It feels so counterintuitive.
It is. It is.
Can you give me like a more concrete example of what it means for a property to only exist upon measurement?
Sure. Imagine a coin.
Okay.
Right? Before you flip it, does it have a definite heads or tails?
No, not really.
Not really, right? It's only when you flip it, when you make that measurement,
Yeah.
that the outcome is determined.
Right.
Right? The act of observation, the interaction
Yeah.
is what creates the context for the property to manifest.
Okay, I think that makes sense.
Okay, good.
It's like the coin exists in this state of potential until it's forced to choose heads or tails
Right.
by the act of flipping it.
By the act of flipping it.
And in the quantum world, it's the interaction, the transaction that serves as that flip.
That's a great way to think about it.
Yeah.
And TI suggests that this principle of contextuality applies not just to simple things like coins,
Right.
but to the very fabric of reality itself.
Wow. This deep dive is really making me question everything I thought I knew about the universe. But in a good way, of course. It's like TI is both a map and a compass.
Yeah.
It helps us navigate the known territory of the quantum world,
Yeah.
while also pointing us toward new horizons of exploration.
I love that. That's a brilliant way to put it.
Yep.
TI doesn't provide all the answers,
Right.
but it gives us a framework for asking better questions,
Right.
probing deeper into the mysteries of the universe.
Speaking of mysteries,
Yeah.
there's one thing I haven't quite grasped yet.
Okay.
Does TI actually make the quantum world seem more or less mysterious?
That's a great question.
Like, on the one hand,
Yeah.
it offers a framework for understanding quantum phenomena that feels more intuitive, more grounded in familiar concepts like transactions and interaction.
Yeah.
But on the other hand, it suggests that reality itself is emergent,
Right.
which opens up this whole new realm of questions and possibilities.
That's a very insightful observation.
Yeah.
I think it depends on how you view mystery.
Okay.
TI certainly demystifies some of the spookier aspects of quantum mechanics, like non-locality and the role of the observer.
Yeah.
It brings them down to earth,
Right.
so to speak,
Yeah.
by framing them in terms of interactions and relationships.
So in a way, it makes the quantum world seem less alien,
Like alien, yeah.
more connected to our everyday experience.
Exactly. But at the same time, TI throws open the door to a whole new level of mystery
Right.
by suggesting that our reality is emergent, that the universe we see is just the tip of a cosmic iceberg.
Right.
It makes you wonder what other incredible possibilities might be lurking beneath the surface,
Yeah.
waiting to be discovered.
It's like we've just started to explore this vast uncharted territory.
Yeah,
And TI is giving us the tools to delve even deeper.
that's right.
This has been such a mind-expanding journey so far.
It has.
But before we get too carried away, let's
Yeah.
take a moment to recap what we've learned about the transactional interpretation. We've covered a lot of ground.
We have.
All right, so welcome back to our deep dive on the transactional interpretation.
Back for more.
Yeah, we've covered a lot of ground.
Yeah, a lot of
From spooky action at a distance
Right.
to the idea that space-time itself
Yeah.
might be emergent.
Right.
But before we wrap things up, I want to
Sure.
circle back to something we touched on earlier,
Okay.
which is you mentioned that TI might actually offer a simpler way of understanding quantum mechanics.
Yeah.
And I'm curious, like, how does TI simplify things,
Right.
especially when we've been talking about such like mind-bending concepts?
It's a good point. Quantum mechanics has a reputation for being like incredibly complex, counterintuitive,
Oh yeah,
and to be fair, it is.
right.
But what TI does is it shifts our focus away from some of the more confusing aspects of traditional interpretations,
Yeah.
like wave function collapse
Yeah.
and the mysteries of measurement.
Yeah, those concepts always felt a little bit too like abstract and mystical for me.
Exactly. TI groans things in a more concrete way by focusing on interactions, on those transactions
Right.
between quantum entities, instead of getting bogged down and trying to explain like what happens when a wave function collapses.
Right.
TI just says, look, these entities are constantly interacting and these interactions are what shape reality.
So it's less about the initial conditions of the universe
Right.
and more about like the processes,
Yeah, the process.
the relationships that drive everything.
Precisely. It's like saying instead of obsessing over where the ingredients for a cake came from,
Right.
let's focus on how those ingredients are mixed and baked
Yeah.
to create the final product.
I like that analogy.
The focus shifts from origins to outcomes, from the what to the how.
Okay, that's really helpful. So I'm starting to see how this shift in perspective
Yeah.
could make quantum mechanics feel less
Yeah.
mysterious and more approachable.
Right, less intimidating.
Yeah, less intimidating. But does simplifying things
Yeah.
mean that we're losing something in the process?
Right.
Are we sacrificing accuracy for the sake of understanding?
That's a valid concern, but proponents of TI would argue that it's not about sacrificing accuracy.
Right.
It's about choosing a more elegant and parsimonious explanation.
Okay.
They would say that TI provides a framework that's both accurate and intuitive,
Yeah,
which is a rare combination in the world of quantum mechanics.
for sure. So it's like finding a more streamlined way to describe the same phenomena,
Yeah,
way that cuts through the cluttering and gets to the heart of what's really going on.
exactly, exactly.
So by focusing on interactions,
Yeah,
TI opens up new ways to think about some of the biggest mysteries in physics.
it does.
For example, we've been talking about this challenge of unifying quantum mechanics and general relativity.
Right.
TI's view of gravity
Yeah.
as an emerging property of space-time could be a key piece of that puzzle.
It could, it very well could.
It's incredible to think that something as fundamental as gravity might not be a fundamental force at all, but rather like a consequence of these tiny quantum interactions weaving together the fabric of space-time.
It's a mind-blowing idea.
Yeah, it really is.
And it shows how TI can lead to these really profound new insights by shifting our perspective
Yeah.
and focusing on the fundamental role of relationships and interactions in the universe.
You know, this entire deep dive has been like a real eye-opener for me.
Good, good.
We've explored so many fascinating concepts from the nature of space and time
Right.
to the role of the observer
Yeah.
in shaping reality. It's clear that TI offers a unique and powerful way to think about the universe.
It really does.
One that challenges our assumptions and opens up new possibilities.
And it reminds us that the journey of discovery is never over.
Right.
TI may not have all the answers,
Right.
but it gives us a new set of tools
Yeah.
to explore the mysteries of the universe. It encourages us to keep asking questions,
Yeah.
keep pushing the boundaries of our understanding.
Well said. So as we wrap up this deep dive into the transactional interpretation,
Yeah.
I want to leave our listeners with a final thought-provoking question.
Okay, shoot.
If space-time emerges from the electromagnetic field,
Yeah,
as TI suggests,
right.
could there be other undiscovered fields
Right.
responsible for other aspects of reality
Right.
that we currently don't understand?
That's a fantastic question to ponder.
Yeah. Could there be like a whole tapestry
Yeah.
of fields underlying the universe,
Right.
each contributing to the emergence of something new and unexpected?
Or could manipulating the electromagnetic field allow us to influence the very fabric of space-time?
Whoa. Okay.
Imagine the possibilities.
Right.
Yeah,
The possibilities are truly endless.
they are.
So to our amazing listeners out there, keep Keep those questions swirling,
Yeah.
keep exploring it, and keep diving deep into the mysteries of the universe.
That's right.
We'll be back soon with another deep dive
We will.
into a new and fascinating topic.
Always something new.
But until then, stay curious.
Farewell, fellow knowledge seekers. May your journeys be filled with wonder and discovery.